Hey people, I promised you an instructional video on doing electron configuration or electron notation. So here is what we're going to do to get you prepped for the test. I know this is kind of hard to see on your end, but I want you to see my pretty face and I want you to be able to see this different version of the periodic table as well. Here's what we're doing. We know Bohr had it kind of okay, but he was wrong about the electrons and how they moved around the nucleus, right? So we admittedly taught you wrong. Sorry, we lied to you, but we're not the first teachers to do that now, are we? So your periodic table, if you take a look at this, here's hydrogen right here, right? Hydrogen's got one proton and it's got one neutron. It doesn't, one proton and one electron. That's it, no neutrons. So here's what Bohr would have done. Bohr would have said proton in the nucleus and neutrons, we ain't got none. And he would have taken that electron and put it in one of these energy levels, and he would have thought it moved around the nucleus like a planet around the sun and everything was hunky-dory. Well, we know that's not true. That's not how it works. So these electrons are moving in these areas of probability. We want you to start calling them orbitals, right? And so the periodic table that you see on the board behind me, which doesn't have the elements in there, shows you these. Oh my gosh.
Please, Trinity Simmons.
Oh, that's okay. Miss Ryan's got to get on there every once in a while. It's totally okay. It happens, right? So that one electron is in what's called the 1s orbital, which you can see right here, right? It's in the 1s orbital, and we've got room for two electrons there, but hydrogen only has one. So the electron notation for that is just going to be in the 1s orbital, okay? There's one electron, and that's hydrogen, right? That's it. That's hydrogen. Now, if you want to see that one up here, you go ahead and click rewind because I'm about to erase it. So take a good look at it right there. Bohr's version, which is not entirely correct, but the electron configuration for hydrogen is 1s1, right? I'm thinking, I'm double guessing myself here. Let's leave that up here. Look at helium on your periodic table. It's on the other side of the periodic table, but it's on that same row as hydrogen. It's right here. It has two electrons, two protons, and two neutrons. Okay? So here's what Bohr would have done. Bohr would have said, all right, helium, you've got two protons in the nucleus, just like so, and you have two neutrons in the nucleus, and those two electrons, we know Bohr at least knew that those two electrons belonged on the same energy level. I like to write them paired up like that, but you can do it. Is this kind of creepy, me coming in from the side? Oh, science. That's how he would have done it, right? Well, those electrons are both still in that 1s orbital. So the electron configuration for helium looks something like this. We have in the 1s orbital, which is kind of a spherical shaped orbital to begin with, two electrons. That's your electron notation or electron configuration for helium on your periodic table, right? Well, it gets a little bit more complex, not much, but a little bit as you go down the periodic table. Let's take a look at our next element down. There's lithium, right? Right there. It has 3 protons, according to the atomic number, and it's got 4 neutrons, which means we've got 7 things in the nucleus. So here's what Bohr would have said. I'm going to jump over here to this side. Bohr would have said for lithium, go ahead and put 3 protons in the nucleus, just like that, and 4 neutrons. But it's those electrons we're worried about. Okay? That first energy level has those 2 electrons. I like to write them paired up. Some people don't, but I do, and I'm making this video, so I'm going to do it how I want to do it. But there's a third electron. Bohr at least knew it belongs on another energy level. And in actuality, it's moving around in a different orbital. It's not in the same area of probability as the other 2 electrons. And so here's how we write the electron notation once we have that third electron on that second energy level. Well, the 1s energy level, the 1s orbital, still has those 2 electrons in it, right? Those 2 right here. So the electron configuration there is in the 1s orbital, we have 2 electrons, okay? But there's that third one, which is, there's no more room in the 1s orbital. We have to drop back down and put it in the 2s orbital. Remember, we like to read the periodic table like a book from top to bottom and from left to right. So in the 2s orbital, we have that one electron, which gives us a total of 3 electrons. These 2 right here and this one right here. Okay? Now, either right now you got the pattern and you're feeling saucy and you get it, or you don't, right? So come in and talk with me. I'm going to choose one a little further down on the periodic table. So for those of you that see the pattern, this is going to start to make more sense. And you can see that a relatively long... Oh.
Riley up. Alan, please come to the front office. Riley, Alan, to the front office.
Riley, you better get yourself to the front office right now. I want to show you that once you see the pattern, these electron configurations look complex, but they're not really that hard once you see the pattern, okay? So let's do one a little further down on the periodic table. Let's go ahead and take phosphorus right here. Look at phosphorus. Holy smokes. It has 15 protons, so it has 15 electrons in this case because it's neutral. So let me erase some stuff on the board and we'll write the electron configuration for phosphorus with 15 electrons. Here we go. Erase, erase, erase. If you want to pause this and take a minute and draw Bohr's model of the atom for phosphorus, go right ahead. It's wildly entertaining. It's a fun thing to do, right? So if I look up here on my periodic table that is not marked with the elements, phosphorus falls right here, right? I got to get there with my 15 electrons. If you're wondering, why do I have to get there? Count with me real quick. 1 electron, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So there's phosphorus right there. Here's how we write the electron configuration. The top s orbital, all the way, let me see if I can point to it, all the way right there, has room for 2 electrons. So for phosphorus, the electron configuration looks like this. The 1s orbital is completely full with 2 electrons. Then I drop down to the next level, starting with the 2s, and there are 2 electrons in the 2s orbital. Now it's full. Now I got something new. If you've been watching this video, we have a 2p orbital, and it's got room for 6 electrons. We haven't made our way down to phosphorus yet, so I know these are all full. So in the 2p orbital, we have 6 electrons. Drop down, and here we are on this side at the 3s orbital. We know that one's full. The 3s orbital has 2 electrons. And now we're finally getting close. We're right here in this 3p orbital. But notice that it only takes 1, 2, 3 spots to get to phosphorus. So we only have 3 electrons there. So the last part of this is going to be our 3p orbital has 3 valence electrons. Can you still see that? Did it sneak in? If I get my big head out of the way, right? That's the electron configuration for phosphorus. All of the elements that come before phosphorus have this same electron notation or configuration until you get to the very last part. These electrons over here, those 3 are really the one that help you identify that this is phosphorus. Okay? Again, if you got questions, come in and see me. We'll walk through each of these. For your test, we want you to be able to write the electron configuration for the first 18 elements on the periodic table. That's hydrogen through argon. And if that isn't awesome, then I don't know what is. Have a fantastic day.